how to solve integral 0 to pi over 2 ln sin x dx. Now foremost what I wish to do is I would like to take let I equal to integral 0 to pi over 2 ln of sin x dx. Now there is a property called as King's property, which is as follows. If you were to be encountering an integral of this fashion, integral a to b f of x times dx, then this is equal to integral a to b f of a positive b negative x times dx. Now this is a very powerful property and we would be applying this property here. So if I were to apply this property, this is equal to integral 0 to pi over 2 ln of sine, in place of x it's going to be 0 positive pi over 2 negative x times dx, which is rewritten as integral 0 to pi over 2 ln of sine of pi over 2 negative x times dx. Now sine 90, this is pi over 2 is 90, right? So pi over 2 negative x is going to be equal to integral 0 to pi over 2 ln of cos x dx. This is what we have got. Now on the left we got I, so if I were to take this as 1 and take this as 2, adding 1 and 2, I added with I would give me 2i, so this is equal to integral 0 to pi over 2 ln sin x dx positive integral 0 to pi over 2 ln cos x dx. So we got this. Now what I wish to do, I would like to rewrite this as integral 0 to pi over 2 ln, you can club them, right? Ln sin x positive ln cos x times dx. On the left you got 2 times I. Now clearly you know that ln a plus ln b is equal to ln ab. So using that we get integral 0 to pi over 2 ln sin x times cos x times dx. Now what I wish to do is, I know a formula, sin 2x is equal to 2 times sin x cos x, but there isn't a 2 here. So what I would like to do is, I would like to multiply here by 2 and divide by 2, right? I would like to do this. So multiply by 2 the numerator, divide by 2. So you got 2 times sin x cos x, which is nothing but sin 2x. So this is equal to integral 0 to pi over 2 ln of sin 2x, you have a 2 here, times dx. Now there is a formula. What is that? Ln of a over b is equal to ln a negative ln b. So by that formula this is equal to, on the left you got 2 times I, integral 0 to pi over 2 ln of sin 2x, and that has to be followed by ln 2 times dx. Now this can be further rewritten as integral 0 to pi over 2 ln sin 2x times dx negative integral 0 to pi over 2 ln 2 times dx. Now ln 2 is a constant, you can take that out. So 0 to pi over 2 ln sin 2x times dx negative ln 2 is a constant, I'm taking it out. So integral dx would give me x. I substitute the limits, I get pi over 2 negative 0. This is going to be integral 0 to pi over 2 ln sin 2x dx negative ln 2 times pi over 2. Pi over 2, both of them are constant, right? Ln 2 is a constant and pi over 2 is a constant. So I will just write them in this fashion. Okay, so now the question comes, how are we going to integrate this? So on the left I got 2 times I. So what I wish to do is, I would like to take 2x is equal to some u, and 2 times dx is equal to du. So dx is equal to du divided by 2. So this is equal to integral ln of sine 2 times x is u and dx is du over 2. So that 2 I am placing that over here. Now when x is equal to 0, u is equal to 0. When x is equal to pi over 2, u is equal to pi. Right. So you can probably write it here. When x is equal to 0, u is equal to 0. When x is equal to pi over 2, u is equal to pi. So this is 0 to pi ln sine u du. Now I can split the 0 to pi. So let me split it. So 1 over 2, I can split this as 2 times integral 0 to pi over 2 ln sine u times du. Right? Now u and du, they are a variable. If I were to replace u by x and du by dx, there wouldn't be any change at all. So you are free to do that. However, 2 and 2 can be cancelled here. So this is going to be integral 0 to pi over 2 ln. So this is going to be ln sin x times dx. Now we actually started with this I. You remember? I is equal to integral 0 to pi over 2 ln sin x dx. So that is going to be the outcome here. But we have this constant. Right, we have this constant here. So I have just shown you the integration of this quantity. Probably I will just say consider integral 0 to pi over 2 ln sin 2x dx. So this is the integration for ln sin 2x dx. So if I were to take this as some 3, so 2i is equal to this one. So therefore I can write 3 to be as 2 times I is equal to, in place of this I need to substitute this. But what is this? This is nothing but I. Right, I just showed you that. So I negative pi over 2 ln 2. This is ln 2. But I can move this I to the other side. So you get 2i negative I is equal to negative pi over 2 ln 2. This is what we have got. So if I were to perform the simplification, 2 times I negative I, that would give me I, right, followed by pi over 2 times ln 2. So what is I? I is nothing but integral 0 to pi over 2 ln sin x dx. So this would mean integral 0 to pi over 2 ln sin x dx is equal to, what's the value we got? Negative pi over 2 ln 2. So that is the solution for this beautiful integral. So it's a lovely integral. I hope you enjoyed this, and practice makes perfect. Thank you everybody.